Okay, guys, I think we can start. Yeah. So before starting with the presentation, I will say, like, if you have any questions, you can put it in the chat box, okay? Or you can just unmute. During the session, it doesn't matter. If you have question, you can unmute and ask, okay? No problem. And yeah. So my session mostly will be interactive sessions, so that, like, maybe I will ask few questions to you, so that maybe you can answer, or you can just put it in the chat box. Okay, that will be great. Okay, it's not like a radio kind of thing. I'm not like preaching everything that I know. It's not like that. It should be like interactive. Okay, it will be interactive. Okay, yes. So today's session is about, like, I will say it's an introductory session. It's mainly discussing about a tool, software tool, okay, which can be used in robotics. Okay, you maybe heard about robotics. I mean, robotics. It's actually a very popular domain, right? So we are going to discuss about a specific tool called ROS, okay, which can be used for programming your robots. Okay, that is today's topics. Okay, and we are not going into deep aspect of ROS, but what I already mentioned, it's like an awareness session, like the opportunities of ROS. What will we get if we learn this? Okay, well, what will we get if we learn this framework? Okay, yeah, so mostly about that. And based on the time, I will discuss the things, like maybe I will shorten some topic, maybe I will shorten, but I'm planning to give an overview of this framework. Okay, and use, like, what will you get if you like this? Okay, so this is what my objective. Okay, so learning robotics using ROS. So this is my profile. Sasha already explained about me, like the things that I am doing. And I also want to give a quick walkthrough of my robotics career. It may help you to build a robotics career. It's not like a big, I mean, what I will say, it's a very simple path. Actually, I started working on robotics from my bachelor degree during my engineering. Okay, in 2000, I think 2010. Okay, then after that, I think I started by doing my final year project. I guess you may be also like, if you're a student, you may be doing your final year project, right? So I started building a robot during my bachelor's. And from that, I created a strong interest towards this. Okay, why? Because I was very passionate in working with electronics, computer science, embedded, then all those stuff, actually, before joining engineering. Okay, in my childhood itself, I was like doing small circuits, and because my inspiration was my father, he was an electrician, so I just got inspiration from him and started working on these stuff from my childhood. Then during my bachelor's, I integrated all my passion into one domain, that is robotics. Okay, from 2010 I'm working, and after my graduation, I got in a small startup company called Asimo Robotics in India. It's actually very popular now. It's a very small company. I was in the founding member, and I worked there for 3 to 4 years. And then in 2014, I started my company called Qbotics Labs. Okay, it's mainly into robotic software development using ROS. Okay, from 2010 itself, I started my interest in ROS as well. Okay, I didn't do my project in ROS. I mean, the final year project, but one of my friend done a project. So at that time, ROS was very, I mean, not very mature. It was very difficult to work with, but I mean, when I heard that name ROS, it's actually, I mean, it looks good, right? Robot operating system. I mean, somebody who's interested in robotics, this word is actually very catchy. So then I started learning, and from 2011 I creating tutorials, YouTubing, then writing blogs, Okay. Then in 2014, I started my own company. And then from 2014, I started writing books as well in ROS. So I temporarily stopped blogging and started writing books. Okay. So far, I could able to like write 9 books. You can just find it from web, I guess. Everything is in Amazon. And there is a small online platform, like a blog I'm maintaining called Robo Academy. Okay. And regarding my work experience, mainly I worked in Asimo Robotics. Then I started my own firm. Then during my work, I did a master's in robotics and automation. And I worked it's small, I mean, 6 months in CMU, which is one of the famous university for robotics. And then I already had a chance to speak in TEDx. I just shared my experience in robotics. And okay, so that's about me. And these are my books. I'm just going through it. Yeah, these are some of the books I reviewed. Okay, so this is the agenda for today's session. Okay. Yeah, so what I'm planning is like maybe some of you may not have adequate knowledge in robot or robotics. Okay, some basics. So I just want to ask, like, uh, like, are you I mean, aware of robotics or robot? Are you comfortable with this topic, or are you hearing this? I mean, are you a newbie? That's what I just want to ask. Like, is robotics is a new topic for you, or whether you already know it? Just comment if you are a beginner in robotics. Just comment. Okay. So some of you are a newbie. Okay. Maybe some of you are not use ROS. That is fine. But I'm asking about the robotics. So okay, yeah. So most of you are like, I mean, I'm not saying okay. So some of you are like very new to robotics, right? That's fine. That's pretty fine. Okay. So before starting with this tool that we are focusing, I just want to give a very short idea. Okay, very brief idea about robotics and robots. Okay, then I will start with ROS. Okay, I think that will be good. Otherwise, you will be, I mean, you will have some confusion. Okay, so those who already know robotics and not in deep, I mean, already have an idea about robots and robotics, like I will take some time to discuss this. After that, we can jump into introduction to ROS. Okay, I hope that is fine for you, because there are a big audience and we have to address everyone, right? Okay, so we will be starting from robot and robotics, robot programming. Okay, then we will start with ROS. Okay, let's start. Okay, so I hope you heard the term called robot, right? But did you like think about what are the main components of your robot? What are the main components? So if you just take a human, okay, what are the main components that we have? We have a lot of sensors, right? We have eyes, we have ears. So these are sensors, okay? And these sensors are connected to the brain, right? That is the brain, right? And we have actuations, we have joints, right? So basically, we are perceiving the environment from the sensors, okay? Then we are connected these sensors into the brain, okay? Then the brain will do all the processing. Then based on the control signal, so based on the decision from the brain, the actuators, that is these joints, are moving, okay? So this is a case for human. So what about robots? So in robots also there are many sensors. So one of the sensor is camera, okay? But when you compare a camera with human eye, like camera is like, no, I mean, it's a very basic form of human eye. Okay, we have a very advanced sensor, I mean, for human. So camera, I will say very basic version of human eye. Then instead of our brain, robots have computers. So there are many computers. Our laptop is a computer, PC, then Raspberry Pi. If you heard about Raspberry Pi, it's a computer. Then if you heard about Arduino platform, it's a microcontroller, right? It's a computer, actually. It's a mini microcomputer. Okay. Then in order to move the robot, there are actuators like motors. Okay, actuators or motor. Okay, there are different actuators. Okay, so this is the main parts of a robot. So if you take any robot, you can find these blocks: sense, think, and act. Okay, maybe the sensor number, the count may be less. Maybe in a robot, in some robot, there will be one sensor. In some other robot, there will be multiple sensors. Okay, so the count actually change. Okay, but these are the three blocks that we can see in any robots. Okay, like human beings. Okay, so just have a look onto the feedback loop. I mean, it's very similar to human being. Like we are perceiving from the environment, we will feed into the brain, then the control signal or decisions are feeding to the joints. Okay, so this is what happening inside any robot. It's actually a loop. This loop is going on, reading from sensor, processing it, sending into the actuators. Okay. Yes. So this is an example, very basic example for an robot, an obstacle avoidance robot. Okay. Obstacle avoidance robot simply means, imagine there is a robot like this. It's going forward, and if there is an obstacle here, okay, imagine there is an obstacle, then the robot will stop and move away from the obstacle. Okay, the primary duty of this robot is like detecting an obstacle in front. Okay, so what are the sensors in this robot? Okay, so for sensing the obstacle, okay, the robot will have some obstacle detection sensor, right? There are many obstacle detection sensor in electronics, like there are ultrasonic distance sensor, IR sensor. So these all sensors can be used to detect obstacle. Okay, so is that enough? Is that enough? No, right? After detecting the obstacle using this sensor, we have to feed into the computer, right? So the computer here, it can be a microcontroller. Okay, it can be a microcontroller or maybe a Raspberry Pi, anything. Okay, then when it passed to the computer is taking a decision. Oh, is the object is very near or very far? Okay, so according to the decision, the the computer will trigger its wheels. Okay, imagine it's a wheeled robot. Okay, so the computer will send the commands to the motors. Okay, so if there is an obstacle, then the wheels will stop. Okay, wheel will stop and maybe move away. Okay, and this loop is continuously running on that robot. Okay, this is a example for an obstacle avoidance robot. Okay, yeah, so this is actually the expanded view of a robot. I mean, if you take any robot, you can find multiple sensors, multiple actuators, and multiple computers. Okay, so if you take any robot, you can find this. Okay, and I just want to introduce some of the components of the robots. Okay, robotic components. So for example, if you want to put any sensors on the robot, there are many sensors available. Some of the sensors are camera. Camera is one of the sensor. Then in order to compute the distance traveled by the robot, there are wheel encoders. Okay, then ultrasonic sensors for obstacle detection and all. Okay, and the examples for actuators are like there are a list of actuators available. Examples like RC servo, then DC gear motors, then stepper motor. These all are the examples for robotic actuators. Okay, and these are some of the sensors that we can use in the robot. Okay, there are some advanced sensors like Velodyne, then laser scanner. So how many of you see a self-driving car before? Maybe in the video or something. Self-driving car, the car without the driver. How many of you see some videos of self-driving car? Anyone? You can comment. Yeah, yeah. I think a lot of people are. Yeah, a lot of people have already seen a self-driving car. Did you observe a sensor on the top of that car? If you are seeing the Tesla, it may not have that sensor, but if you see a self-driving car from Google, Waymo. Okay, it's not. I mean, Waymo is actually a different company now. Did you observe a sensor on the top? Okay, there is a right. Yeah, that is this sensor. Okay, it's called a lidar. Okay, and the Velodyne is the company name. Okay, there are different vendors that is providing lidar, but most popular vendor is the Velodyne. Okay, Velodyne is there, then Outster is there, then RoboSense. So there are different companies manufacturing lidar. Okay, so the robotic car, from the word itself, it's a robot. It's actually a robot. Like the self-driving car is a robotic car actually. So for the robot, we have to connect sensors, right? So the one of the important sensor in a robotic car is the lidar. Okay, and in the old prototype of the self-driving car, they have used laser scanners. Okay, laser scanners. Then for autonomous robots, that is one of the topic that we are discussing tomorrow. Not deep. It's about autonomous robots and ROS. Okay, so on that robot, mostly like indoor robots, we are using this kind of depth camera. Okay, depth camera is like you can see my I mean, I'm using a webcam here. Okay, so you can see, right? You can see the RGB, the color image, right? But if you want to get the depth means what is the distance from the camera to this mic. Okay, if we want to find that kind of information, we have to use the depth camera. So it will have the RGB information. RGB information means the color information, and also the depth information. Okay, so that depth information is very, very useful in robotics. Okay, because as humans, we can detect the depth, right? Like if I'm seeing an object, I can actually perceive almost the distance from my eyes to that object, but robots can't perceive that. Like robots should need some sensor which can give the depth information. Okay, so we have the stereo vision, like using the two eyes we can perceive the world in 3D. But for robots also need some two cameras for pursuing the 3D information. I mean, otherwise, if there is no stereo cam, we can use a depth cam as well to perceive the depth of the environment. It's actually working in a different technology using IR, time of flight technology. It's project some IR radiation, IR light into the environment, then it will collect the reflection, then compute the depth. Okay, so these are some of the sensors, and the basic sensors for obstacle detection is ultrasonic distance sensor, then IR sensor. Okay, so these are the sensors that we are using. Then the most important part, I will say, the brain. Okay, the brain. Why? Because like for humans, if we lose some sensors, imagine eyes or hair or skin, anything, like if we lose, we can still live, right? Okay, but what happens if the brain has some problem? I mean, if the brain is not functional, it's like maybe we can, I mean, live, but we will not be functional anymore, right? So it's the same situation for robot. Like if the computer inside the robot failed, everything will fail. Okay, so that's how the computer of the robot or the brain in human is that much important. Okay, because each human is different, not because of the difference in the sensing. Okay, we are, I mean, if you take two human, they are almost seeing the same thing. Okay, but the difference is in the intelligence, or how they're using their brain, or how they're using their intelligence. Okay, so that's where the difference is. The same thing applying to robots. It's not like how much IQ you have. It's actually about how you use that IQ. Okay, so similarly in robots, it's not about how powerful computer that you are using. It's about what software you are writing in the robot, okay, in the computer. Okay, just a second, let me just open my window. It is too hot here. Just a sec, I will come. Okay, sorry for the interruption. Okay, yes. So what I'm talking about was the brain of the robot. Okay, it's not about like I mean using a very powerful brain. It's about the software. Okay, it's about the software that we are deploying inside the brain. Okay, the same situation for human. It's not about high IQ or something that matters, but it's about how we use it, right? Because for me, like when I'm doing my bachelor's, I was just benchmark myself as a very average student. But one of the difference that I have seen in me is that some of the like high IQ students, they are not very interested in engineering or interested in technology. They just want to complete the course and they just need a job. But for an average IQ student like me, I was very passionate actually. So that actually drives me to do different things compared to them. Okay, so if we compare the IQ, I'm an average student, but when I'm using my average IQ to a maximum level, then that makes difference, right? So for you as well, like if you are treating yourself as a like average student, that doesn't matter. That doesn't matter, but it's about how we use it. Okay. Yes. So these are some of the computing units that we can use in the robot. Okay. So like mostly the robot will be moving. There are robots that doesn't move. I mean, like there are robots like robotic arm, which will be placed in some location and it can perceive. I mean, it can take the objects like that. Okay, there are robots which is moving through, I mean, using wheels. Okay, so there are different configurations. So mostly when you work with robotics, we are preferring like small form factor computers. Okay, very small size computers, which is having a lot of computation power as well. So imagine like Raspberry Pi, NVIDIA TX2. So these all are categorized into single board computers. Okay, single board computer means the entire computer in miniaturize it to miniaturize to a single board. You can see the Raspberry Pi board, which is a very popular board, which is having an SoC, system on chip, which is having processor, GPU, RAM, and everything. Then it is also having USB port. So it's like our laptop or computer. Okay, so this is a very commonly using SBC, and also like if you need more power, then I will suggest NVIDIA TX2, NVIDIA Nano, Jetson Nano, or Savior. So these are the boards that we can use in the robot. And also like if you are looking for a the problem with the Raspberry Pi and NVIDIA, these things are ARM-based processor. Okay, so there will be I mean, there will not be full support for some libraries and all. But if you are looking for a miniaturized desktop PC, then you can go to Intel NUC. Okay, this is a mini PC that we can use in robots. Okay, very powerful. And you can simply use it like a desktop computer. Okay. Okay, so this is a important part of robot. Okay, and then I'm coming to the important part. Again, we have seen the computing. Okay, then the next step is how we are going to use this computer. Okay, so that is using the programming. Okay, so the intelligence of human or robot is how we use the computer or how we use the brain. Okay, so in robots we can implement the intelligence using programming. Okay, We can. So that is what robot programming is. Okay. So for the robot programming, what we have is we have data from the sensors, right? For a robot, we will have, the robot will have many sensors, right? And your program should receive the data from the sensor. Okay, so your program is having the sensor data. Then your program should process it, right? Then not only processing, after processing, you have to make a decision based on it. Okay, that the program inside the robot that I'm talking. Then after taking the decision, it should be sent into the actuators. Okay, actuators means the motors. Okay, so basically the robot programming is the modeling of the behavior of a robot using a programming language. Okay, you can use any programming language, but the commonly using programming languages are C++ and Python. Okay, so these are the two popular programming languages that we are using in robots. Okay, but you can use anything like C or like Lua or MATLAB you can use, but mostly C++ and Python is preferred. Okay, C++ is for performance and Python is for like quickness in the prototyping. Python is very easy to code compared to C++. Yeah, okay. So for the robotic programming, the input of your program is the sensor data and the output is the signals to the motors. Okay, so this is what robot programming is, and this is what creates an intelligence in any robot. Okay, so did you see a scope in it? Did you see a scope in robot programming? Can anyone say like, so if you take the robotics as a whole, this area, the programming area, I will say that is having more future. Okay, I'm not saying other things are like a symbol or not important, but I'm saying like in the case of computer, okay, in the computer world, actually Microsoft gained a lot of traction because of Windows operating system. Okay, Microsoft and Linux, okay, it's actually gained traction because of the software. Okay, so I am also, looking like that, the robot programming, the scope of robot programming, like we can create the intelligence in the robot by programming. Okay, so like Microsoft gained traction in the computer world, now it's the ROS is going to gain momentum in the computer, robot programming. Okay, so that is what I am, I'm planning to, that's what I have to say about the robot programming and ROS. Okay, yes. So Harshit is asking, there is a question, yes it is, but how is it different from AI? So the AI and everything is belongs to the robot programming. If you take robotics, it's actually a multidisciplinary branch of engineering, or like we can say it's a combination of many engineering domains. So it is having electronics, computer science, AI. It's a combination, because for adding intelligence to a robot, we can use AI algorithms like the deep learning models and everything. So if we can say AI is a separate domain, and yes, we can say AI is a separate entity, but we can use AI in robotics as well for creating the intelligence. Okay, so these all are like interconnected. Okay, yes. Yes. So if you want to program a robot, basically we can think about two approaches. Like if you want to program anything like a computer or a microcontroller or anything, either you can take the existing things, right? Existing frameworks to program a computer, a robot, or you can start writing from scratch. Simple, right? Simple. So if we want to take the existing components or tools to program robots. So what is advantage? What is the advantage of using existing components? Like it will be very fast, right? We don't need to reinvent the wheel, right? That is the terminology that I have to use. Like if I created a program for a robot, okay, I already created one. Then you don't need to like reinvent the same. Okay. Instead, you can take my code and maybe perfect it or fine tune it. Okay. So that is the first approach that I'm talking about. So in order to program a robot, you can either take an existing framework or a tool and then program and fine tune. Okay. Or you can start from the scratch. That is also possible. So if we start from scratch, the bad thing is that it will take a lot of time. Okay, but I will say we will get the complete control of the code. Okay, if you are writing your own code, you will get the complete control. So you can select any method. Okay, but mostly companies and research are preferring, I will say, they are using an existing framework. For example, you guys may be using MATLAB on your work. MATLAB. Okay, I think you heard about MATLAB. So MATLAB, what is MATLAB? MATLAB is simply a software which is having a lot of modules, right? And these modules will have some implemented a code for an existing algorithm. Like if you want to do an FFT, if you want to do some image processing or anything, MATLAB will have a function for that. Okay, so we are not reinventing or we are not rewriting these functions. We are just using it. So the same thing happening for the first approach. Okay, so the ROS is actually a tool. Okay, it's a software tool, or I can say different words for ROS. I will say ROS is a software tool. Okay, I will say ROS is a software framework. I will say ROS is a middleware, robotics middleware. Okay, so there are different terminologies for ROS. Okay, but ROS is simply an existing stuff. Okay, existing framework or tool or something. Okay, that we can use to program robots. Okay, okay. I think that is the first approach. And second, and you may be heard about the Arduino framework. It's a very popular framework you might use. You might have seen the Arduino. Maybe if you are not seeing the Arduino board, maybe I can just show you in the browser. I think you might have seen this kind of boards, Arduino board. So this is an like I will say this is an existing framework. Arduino board is actually having a microcontroller. Okay, and you can program a microcontroller using like assembly language or embedded C, or using the framework of Arduino. Okay, framework of Arduino means Arduino is a higher level language implemented based on the the embedded C and all. Okay, so we don't need to write the boring assembly language. And if you are not familiar with embedded C, then you don't need to write that kind of code. It's actually very easy to work with Arduino code. I mean, if you are seeing Arduino code before, I think you will understand. Like you can create some sketches like this. It's a very easy way to implement. Like for example, in order to blink an LED, if you are working with embedded C and all, you have to write, I think, maybe 20 lines of codes and all. Okay, but if you are working with Arduino, I will say this much code is enough to blink an LED. Okay, and so this is an additional framework, I mean existing framework. Okay, so you can use it for programming. Yeah, and easily readable. Yeah. Yes. Okay, so I think you got a small understanding about robotics, robot, and the robot programming, and how important is the robot programming. Okay, and we also discussed that ROS is actually a tool or software framework to program robots. Okay, yes. So now I am going to a block diagram. Okay, it's not complicated at all. Okay, it's called, I actually created this thing like robot development cycle. This is from my experience. Okay, robot development cycle simply means when you create a robot, what are the procedure that you have to follow? Standard procedure you have to follow. Okay, mostly when you create a robot, maybe a line follower robot or something, you may not follow these procedure mostly, but these are some standard set of, I didn't mention all the step. I mean, these all are abstract blocks. Okay, and I just want to show you where we are using ROS in this. Okay, in the entire robot development cycle where we are using ROS. Okay, that is my objective. So first thing, if you want to create a robot, if you are planning to create a robot, first thing, we will have some set of requirements, right? We will have some set of requirements. So for example, I need a robot, an indoor robot, which can autonomously supply food in my home. Okay, so it will fetch. So the objective is like, my mom will put the food on the top of the robot, then mom will press a button, then the robot will come to my table, then I will take the food, then I will press a button, then the robot will go to the kitchen again. Okay, so this is the robot that I am planning to make. Okay, so I actually mentioned what is the thing that I have to make, right? So that is actually the requirement, right? Okay, so I have a requirement. I need to design a food delivery robot that is working on indoor, and there are a set of things. Okay, so that is the requirements. Okay, maybe I can use the pen. Okay, so we got the requirements, right? Then after getting the requirement, I have to build this robot, right? So either I can buy a new robot. That is a way. But if I'm planning to design, or if I want to create my own robot, the next thing is designing, right? I need to design. Like for a robot, we already mentioned that it should have sensors, computers, and actuators, right? So how to select these sensors, how to select the actuators, and how to select the computers. Sorry. And also how big it is, how I mean, what is the payload, or what is the payload of the robot, all these things. Okay, it's not like simple plan. It is involving some mathematics. Okay, there are some equations to design all these things, like to estimate the motors that we have to use, what is a torque, and all those stuff coming into the design phase. Okay, then after designing all this stuff, we will do the 3D modeling of the robot. 3D modeling. Okay, 3D modeling, I think you already know, like creating a 3D model using, there are many softwares like Fusion 360, SolidWorks. Maybe you can just search for. There are many CAD tools available. So these are some of the tools that we can use to create a 3D model of our robot. Okay, why this is important? Because in the design phase, we may sketch the robot dimensions and all, but in 3D model, we are like we are building the real robot we are actually building the robot in 3D. Okay, so you will get a good understanding of how the robot looks like, and you can just do some modifications. Okay, and one of the use case of the 3D model is the simulation. Okay, like after doing the 3D modeling, okay, you are not directly creating the hardware. Okay, what you are going to do is you are simulating the robot. Okay, simulating the robot, which is one of the important part of robot development. Okay, simulation means, I think you may have seen this kind of thing. maybe I can show. Like, instead of creating the actual hardware, you are working in a virtual world in order to test or in order to validate your design. Okay, this is very, very important because robotics is very, very costly thing. Like, building robots is very costly. You have to buy different sensors, actuators, and everything. Okay, so before building or a before buying a components, robot components, make sure your design and everything is correct. Okay, so the simulation of the robot is super important to validate your design. Okay, and also using the simulation, you can create software for the robot. Okay, you can create the software, you can develop. Okay, then after simulating, you can go to the prototyping. Okay, prototyping of the real robot. Okay, you can buy the necessary components, then testing the robot, assembling it. Then again, we can reuse the software that we have used for simulation to the actual robot as well. Okay, maybe there are some differences, but we can reuse most of the software for the simulation in the actual robot. Okay, finally, we will deploy. And when we deploy, like, we will get the autonomous robot. Okay, so where we are in the entire robot development cycle, where we are using ROS. So that's where here, this section. So the ROS can be used to slightly 3D model. I mean, it will help to create the basic 3D model of the robot. Okay, so very basic model. Then it will help you to simulate the robot. Okay, in the sense, ROS is coming up with a set of software and simulators. Okay, so you can simulate the robot using a the integrated simulator is called Gazebo. So you can simulate the robot like this. Okay, and you can program the robots using ROS. Okay, so ROS is coming in this area mainly for simulation and the software development of the robot. Okay, so there is a question from Harshit. Can you brief us about the simulation software for a robot? Yeah, I can give a small idea. Like, the simulation, how it is working is like, we are having the 3D model of the robot, right? Okay, then the 3D model of the robot can be imported into the simulator. Okay, and it's when you import the simulator, the purpose is we are actually simulating the real robot. Actually, we are planning to simulate the real robot in a virtual environment. Okay, so in order to create a real robot behavior, you have to assign the parameters like weight. Then there are a lot of parameters in a mechanical structure, right? So you can model all this stuff into the simulated robot. Okay, then the robot will work like the actual world. Okay, it will be more perfect. Okay, it will be more perfect than the real robot, because a real robot will have issues. Okay, and noisy, it will be noisy, but from the simulator we will get an idea how the system works. Okay, so some of the examples of the simulation I will discuss in the upcoming lectures. I mean, like, not lectures, in the slides. Okay, so yeah, so example I can mention. And Harshit, does this also include the simulation of electronic? So there is no simulation of the circuit. Okay, for that simulation, we have to go with there are some simulation for the Proteus. I think I know, I work with Proteus, and there are many simulations software for simulating embedded and also the circuit. So that is not included, only the robot. Okay, the robot software. Okay, no, and we don't need to we don't need to simulate the electronics. Okay, actually, instead of electronics, we can write a software. Okay, we can write a software module that is replacing electronic simulation in the robot simulator. Okay, so in the robot simulator, we don't worry about the electronics actually. Okay, we are actually replacing by a fake software module. Okay, which will work similar to the electronics. Okay, yes. So let's go to the next slide. So ROS is one of the existing robotics software framework, and there are many other frameworks available, like OpenCV is for computer vision, which is actually integrated to ROS, and also you can use it independently, which is using for computer vision application or robotic vision application. Okay, like we are getting an image, then we are processing, and yeah, like that. And another important library is Point Cloud library, okay, which is using for processing the data from the LiDAR or the Velodyne LiDAR that we have mentioned. Okay, so it's actually a 3D data. Okay, we can use the point cloud data for processing 3D point cloud. Okay, and the Gazebo is also coming up with ROS. And one of the other framework is OpenRave, which is for motion planning. It's all connected to ROS. And some of the examples for simulators are webboards. Okay, maybe I can show you that. You can just search for webboards in the Google. You will get the webboards. Okay, this is again very good simulator that you can think as a replacement for Gazebo, which is having a nice UI and all. Okay, webboards was actually a commercial simulator before. It was a paid one, but they made it open source now, and it's fully supported with ROS. So you can work with ROS and webboards. Okay, webboard. Maybe I can just share the link. Okay, there is a question. What do you mean by a meta OS? Yeah, that I can explain in the upcoming slides. Is a simulation based on the dynamics equation of the robot or by assembling the links and joints as a figure? Okay, so while simulating the robot, we are actually simulating the kinematics and dynamics of the robot. Okay, so we can actually mention, we don't need to like mention the equations and all. What we have to provide is the mass, inertia, then collision, friction, damping, all this stuff you can mention. Okay, then the kinematics, the joints, links and joints, all the stuff. Okay, so like the things that is inside a robot, you have to put all this information in the simulator itself. Okay, the kinematics and dynamics. Okay, so then that will be simulated in the simulator. Okay. Okay, so the next question is, what is the difference between PCL and PCL2, which we see in RVs? Okay, so it's actually a different question. I mean, not a basic question. So it's actually different ROS messages. Okay, PCL was an old ROS message that is used in previous ROS distribution, but currently we are using the Point Cloud 2, which is mainly for the visualization purpose. Okay, so PCL2 is actually we are using in the latest distribution. It's just PCL is an old one. That's it. Okay. Oh, okay. Okay. I have sent the link to one person. Okay, I think the link of webboards is sent to everyone. Okay. Okay. Yeah. Sorry, Winston. I think I sent to you only. Okay. Yes. So other simulators are like Coplia Robotics. Coplia Sim is again one of the simulator that I work. It's again very interesting simulator. You can have a look on it. Oh, it's a video. You can simulate like industrial robots and any kind of robots. Okay, very user-friendly interface and all. Okay. Okay. And these are some of the popular programming languages that we are using in robots. Okay, robots like C++, Python, Java, MATLAB. Okay. Okay. Now, so you had a, I think Winston had a doubt regarding what is a meta operating system. Okay, so I just want to show you these two robots. Okay, two robots. Okay, so for this robot, this is actually basic. It's a line follower robot. Okay, line follower meaning it is following a line, a black line, basically. Okay, so in this robot, do we need to put a big computer on the top of it? And do we need an operating system, or do we need much, complex software on this robot for doing the line follower? Yeah. So as Winston mentioned, it's very simple application, right? It is having one sensor, then it is controlling one motor, right? Right? You got it, right? So you can use maybe a single microcontroller or some digital circuits for controlling the line follower, right? But what about this? For this robot, it looks complicated, right? It is having two arms, then there are multiple sensors. So we need an operating system. We need a powerful computer to process all the data from the sensor, and then to take a decision based on this sensor, and then control the actuators, right? So for if we are using some computer, we need an operating system, right? We may need operating systems like Linux or Windows. Mostly we are in robots, we are using Linux based because it is open source and fully customizable. Okay, so in complex robots, we need a full-fledged PC, okay, and with a operating system installed, okay. Then you are going to deploy your programs on the computer, on the operating system, okay. So you can compare, like for simple robots, we don't need a computer and operating system, but in complex robot, we can install we can put a computer and install operating system on it. Okay. So what is a meta operating system? And maybe I can explain it now itself. So the word ROS stands for Robot Operating System. So you might have some confusion, like, is it a real operating system like Windows, Mac, or Linux? No. Okay, it's not. The word actually saying it's an operating system, but it is a meta operating system, or I will say it's a software tool or software framework. Okay, the word meta operating system means it is having some features of an operating system. Okay, if you know the features of an operating system, like message passing, then threading, multi-threading. There are a lot of features in an operating system, right? So like that, RO is having some features of the operating system, real operating system. So that's why it's also called a meta operating system. Okay, but it's not a full-fledged operating system, but it needs a host operating system to run. Host operating system means you need maybe Ubuntu or Windows or Mac to install ROS on it. Okay. Yes, so that is actually ROS. Okay, and for robots, for robot computer, we are mainly using a Linux-based distribution. Okay, yes. So now only we can start with ROS. Okay, so in order to start working with ROS, for programming robots, I think these skills, I will say these are the prerequisites, minimum prerequisites to start with ROS. You should know the Linux environment, Linux commands, then C++, Python, anything will be fine. But I will say if you know C++ and Python, it will be much better. Okay, because Python is using in small program for scripting, and C++ is using in like for performance. And if you know these, you can start with ROS. Okay. Yeah, so in the meantime, I can take some questions. Is Raspberry Pi with 512 MB RAM enough for image processing? Yes, you can do image processing, but like I said, it's not only about the size of the or power. how powerful is the computer is. It's about how better our software is. Okay, I can say a small example for the performance of your software. Like when I was in a CMU, I attended a session from iRobot. Uh, I, I I think you maybe hear about iRobot company, which is supplying the um, vacuum cleaner robots. Okay, so they explained, they actually implemented. So what this robot does is that the robot will go around in a room and clean it, and it will not go in the area that is it's already cleaned. Okay, so it's actually a very tough problem. Like it's going randomly and autonomously navigating around the room and cleaning, right? So they just implemented this entire algorithm, okay, entire algorithm in a single microcontroller. It's a single microcontroller. So just imagine an autonomous robot is working using a single microcontroller. Maybe imagine you can take Arduino microcontroller. Everything is running on a single microcontroller. So you can run your program on maybe 512 MB of RAM Raspberry Pi or much higher than that. And it depends on how good your software is. Okay, so you can run, and based on the optimized, I mean, based on the optimization you have done on the software, it will work that much better. Okay, yes. And another question, how about only C language? Yeah, so if you know C language, that is actually a foundation to learn C++ and Python. Okay, so I will suggest you to explore the object-oriented world that C++ and Python provides. Okay, so it will be good, because for ROS also, if you want to program using ROS, the main support is with the C++ and Python. Okay, yes. So we can just quickly go through ROS. So maybe I can quickly go through the ROS thing. I'm just skipping. This was my final year project during my bachelor's. This is how I started with robotics. It's a social robot. I'm just skipping that. I was just saying a use case. So ROS is an open source robotic software framework. Okay, and it's also a middleware. Okay, it's not a real operating system. I will get back to with the middleware. And it needs a host operating system to run. Okay, so currently I mean the latest update, ROS website is actually updated. Okay, this is the official ROS website. Okay, so I'm just sharing the link. Okay, so there is another question. What are the basic maths concept needed for robotics, and from where to learn? This is a very important question. I just want to answer that. Yeah, so robotics, if you learn the degree in robotics, the basic prerequisite is you need the knowledge in algebra, linear algebra, that is that metrics, vectors, all these things are very important. Okay, so the max is a foundation of robotics. Okay, and the robotics is not very easy that you think. Okay, I'm not I'm trying to panic you if you are interested in robotics. I'm saying the reality. The thing is that these all things, these robots are mechanical structures, right? Okay, and in order to move all these joints and all, we need to model all these things in max. Okay, like if a hand is having 7 joints, in order to move from one position to another, we need to apply max. Okay, so if you are planning to pursue maybe bachelor's or master's in robotics, make sure your max is good. Okay, one of the problem with the Indian education system, I'm not like teasing anyone, the thing is that we are learning a lot of things. Actually, in India we are learning max a lot of things, but we are not applying it. Okay, the things that we are discussing in robotics is the things that we are learning in engineering. Okay, but at that time we don't know where to apply. Okay, so based on that, because of that, we will forget everything. Okay, so this is what happened to me, because after my bachelor's degree in 2011, I joined in for master's in 2016. Okay, so at that time I was like fresher, like for theory, but I could able to I mean uh, did that course well, and I earned second rank in that. It's because of my passion, I will say. Yeah, so you can just uh, just think like to work with real stuff, real algorithms and all. The max is super important, but the ROS and all is the application part or implementation. Like when you implement some algorithms or some application, you can use this as a tool. That's it. Okay, I'm not saying learning ROS is everything. Okay, it's nothing, it's just another tool. Okay, it's just another tool. Okay, but the important part is how you understand the robot as a system, and how you yeah, it's all about modeling, mathematical modeling, how you model everything and conceive your idea using max and implement using tools like ROS. Okay, so now our discussion is mainly only the ROS. That's why I didn't mention much things about that. Much about robotics and all. Yeah. Yes. So we have seen the website. You can have a look onto that website. um, so from the getting started, everything is there, and there is a new video they have uploaded, what is ROS. But today only I'm seeing, actually they released this new website yesterday, but the problem is this video may be not good for beginners, I will I will say, because it's slightly confusing. You can just watch this video after some time. Yeah. Yes, so there is a question, where did you so I can say from where I did my master's. So I was actually working. I am basically from Kerala, so I was working. I have a company called Qbotics Labs. So, but I actually invited for a ROS workshop in Amrita University. So then I heard about their course. Their course actually oriented for software. So I thought, like, what about doing work and do a master's in robotics from Kerala itself. So but at that time I couldn't stop my company and go abroad for doing masters. But if you are like a student, I will strictly, I will say, like, if you have some financial backing and all, you will get more exposure if you are doing in US. Because after my masters, I have worked in CME for a while. At that time, I got an understanding how exposed they are, how much exposure they are getting. But my personal preference is staying in Kerala, so that's why I'm here. But if you are like open to work in any countries, I will say like US you can prefer. There are a lot of opportunity in robotics, and also Europe. Okay. Yes. Okay. So yeah. So if you want to start with ROS, you can install ROS from the following instructions. Just a sec. There is an option called getting started, and there is an option like this. So there are two versions of ROS, ROS 1 and ROS 2. So ROS 1 is stable, ROS 2 is latest, but I will not say it's too stable. So if you want to work with ROS 1, ROS Noetic is latest version, just click it. And this installation instruction is going to the Ubuntu installation. Ubuntu based installation. So you need an Ubuntu operating system. Okay. So you can install Ubuntu operating system on a VMware like this. Okay. It's a virtualization software. And inside that you can install Ubuntu and install ROS using the following instructions. It's very simple. just copy paste these commands. That's it. Okay. I also like created a small script for installing ROS. So maybe I can just share. So it's a one-line command which can install ROS Noitic on your computer. And I also like just mentioned a basic video. Yeah, so that is the installation. Okay, you can basically install ROS on the Ubuntu Ubuntu PC. Okay, Ubuntu based PC, or you can install in Windows. That is not recommended. I mean, you can install, you can work with it, but I will say to start with, you can prefer Ubuntu, okay, which is the mostly supported operating system. Okay, so after installing, you can confirm the ROS is installed on your computer using this command. So it's basically coming up with the versions of ROS. Okay, yes. So ROS Noitic is what I'm using, and I'm using an Ubuntu version 20.04. Okay, so this is the installation instruction, and I just want to focus on this thing. Okay, so after that, I will quickly go to the distributions of ROS and then application. Okay, so because of the lack of time, we have to skip some slides. Okay, so this is what ROS about. Okay, this is what ROS about. Okay, so there is a question: is it possible to install ROS version on the same melodic? Yeah, so there is a problem to install ROS on. Yeah, so like if you want to install ROS Noitic, they will say you can install ROS Noitic on specific Ubuntu versions. Okay, currently Ubuntu 20.04 is only supported for Noitic. Okay, Ubuntu, they are actually mentioning Ubuntu 20.04 is only available, okay, for installing. For ROS Melodic, which is the previous distribution, you can install ROS Melodic on 18.04. Okay, so that's how you can't install ROS Melodic on 20.04. Okay, yes. So this is the ROS equation. Okay, I will quickly go through. So the ROS equation is like, these are the main components inside ROS. So the main part of ROS is called plumbing. Okay, it seems interesting, right? Plumbing. Okay, so I will explain what is plumbing. Okay, I will explain these things, and I think I'm planning to switch into some videos and application. Okay, because of the lack of time. So plumbing is so if you're creating a complex robot, okay, like we have seen earlier in the slide, you will have a computer, right? The robot will have a computer, and on the computer there may be some operating system installed. Okay, and in the operating system, imagine it's an Ubuntu operating system. You are writing some programs, right? So if you have to work with many sensors, okay, many sensors and actuators, you have to write multiple programs to handle all these things. Okay, it's very difficult to write a single program that is doing all the job. Okay, and writing a single program for controlling a complex robot is not reliable. It's not good actually. Okay, so in robotic programming, what we will do is we will write separate programs. Okay, separate programs. For example, here you can see this is a robot computer. Okay, this is the robot computer, and inside the robot computer there are these green things are programs. Okay, so the camera is the camera data is reading by camera driver, lidar data is reading by lidar driver, the encoder is reading by the encoder processing node. So these all are some programs written in C++ or Python. Okay, and the navigation node is another program. Motor controller node is another program. Okay, so there are for example, there are 5 programs running. Okay, and you can see there is a connection between this program. Okay, so this connection means the camera driver is sending some data to navigation node. LiDAR driver is sending some data to navigation node. Encoder node is running, sending a data to navigation node, and navigation node is sending some data to motor controller node. Okay, it's like it's a communication. Okay, so what is happening? The camera driver is exchanging some data to navigation. It's actually involving exchanging of data, right? Exchanging of data, sending and receiving. Okay, so actually the robot operating system is for this purpose. Okay, robot operating system is for communication of data between different programs or different nodes in your computer, right? Like if you write one program using ROS function, ROS APIs or ROS function, from your program, you can send a data to another program. Okay, and another program can send another data back to your program. Okay, so this is actually called the inter-process communication. Inter-process communication. Okay, so I think you have got this idea. The main part or main function of ROS is it is providing this inter-process communication, which is very useful in robot programming. Okay, so there is a question like tunneling. Yeah, sort of. And Mohammed, do we connect these nodes using launch files? So the connection of these nodes are happening like, for example, the camera driver is sending a type of data. Okay, and the navigation node is expecting the same type of data from a same data bus or something. Okay, then the ROS will interconnect these two nodes. Okay, so then the data will start flowing from camera driver to navigation node. Okay, so I'm only saying the abstract of it. Okay, because of the lack of time, I think I have to go fast. And here he mentioned launch files. Launch files are the method or it's a way to run many nodes or program in a single command. Okay, so if you want to start these 5 programs in a single command, you can use a thing called launch files in ROS. Okay, so basically the heart of ROS is the inter-process communication. I hope this is clear to you. Okay, this is the important part of ROS. ROS help you to send and receive data between different processes that is on the robot computer. Okay, so based on that, based on the communication, we have tools available in order to inspect the data flowing through these nodes. Okay, and based on these communication framework, we have some capabilities. Okay, capability, which is very important. The capabilities of ROS are like very important and very popular. If you want to create an autonomous mobile robot, if you want to create a robotic arm, then using these capabilities, you can build your robot without doing any code at all. Okay, any coding at all. And there is a great ecosystem around ROS. Ecosystem means developers, open source developers are there, then there are a lot of support you will get. Okay, so this is ROS equation, and this is what ROS is. It's a communication framework or communication middleware. Okay, middleware means it's a software acting between operating system and the developer. Okay, it will make a developer program easy. Okay, so ROS is a framework, communication framework, which can be used in the programs of the robot to send and receive data. That's it. That is the simplest definition for ROS. Okay, so while working with complex robot, you will understand the importance of using ROS. Okay, so let me just show you something like, so this is in programs running on a robot computer. So you can find 6 programs running on a robot computer. Okay, can you say what is this structure about? What is this structure? Can anyone say? Yeah, the individual things are nodes, but what about this entire structure? Yes, so as Vedant says, it's a graph, right? It's a graph. So what ROS actually creates is that it's create a graph of process. Okay, what is process? A process is a running instance of a program. Okay, so what ROS is doing is that it's literally creating a graph of nodes. Okay, nodes or process. Okay, and these nodes are communicating with each other like this. Okay, this is a sample graph. Okay, so when multiple nodes in the robot computer are communicating with each other, it forms a graph. Okay, graph of nodes, and it's called ROS computational graph. Okay, ROS computational graph. Okay, this is a main concept in ROS. Okay, ROS creates a computational graph, and then see there are some terminologies associated with this computational graph. For example, program 1 is sending a data to program 2, right? So we are saying program 1 is publishing a data, program 2 is subscribing to the data. Okay, so in order to send a type of data, for example, a type of data from program 1 to program 2, there should be a channel, right? There should be a data channel or data bus in between program 1 and program 2. Okay, so what program 1 can do is it can create a data bus, okay, data bus, and it can send data through it. Okay, then what program 2 can do is it can subscribe to that data bus and receive the data. Okay, so here in the ROS computational graph, the data bus established between 2 nodes is called topics. Okay, it's called ROS topics. For ROS topic, there will be a name for each database. If you are creating, you can create a database actually. So you can give a name. For example, here the name of the database is called Lentin, and the type of data flowing through the database is called it's an integer. Okay, so there are different kinds of data you can send, and you can assign the topic name as well. Okay, so you are familiar with the ROS topic and the ROS, the type of data is called ROS message. Okay, so these are some of the terminologies associated with the computation graph. Okay, so I think you got an understanding. So I just want to show you a very basic example for showing this communication between nodes. Okay, so here I'm just showing the communication between 2 nodes. Okay, so I'm just starting a node called, this is a example node which is present when you install ROS. It's called talker, and then if you start listener, this is another node. So what happening is that the talker and listener are working. And do you want to see the computational graph? We can see by using a ROS tool. So this is the computation graph. Okay, this is a computation graph. So talker is one node, listener is another node. Talker is created a database called chatter or ROS topic chatter. Then listener is subscribing to that database. Okay, so this is how ROS system works. Okay, it's a very basic example that you can try. Okay, and there is another simulator available in ROS called ROS Turtle Sim. So I just want to show you that as well. If you want to learn ROS more, there is a simulator available, which is an interesting simulator for learning ROS concepts like this topic, ROS message, then computation graph, all those stuff. Okay. Yes. Now I'm just switching into some capabilities. Okay. Before that, just want to show you some of the tools of ROS. One of the tool is called RVs. Okay, it's a 3D visualization. RV stands for ROS Visualizer. Okay, and this is actually a tool in ROS to analyze to just check the topics from different nodes. This is another GUI tool from ROS. And the important stuff that I want to emphasize is the capabilities. Okay, just see this video. So this video shows the most popular application of ROS called navigation. Okay, this is how most students or people are choosing ROS. Okay, you can implement the autonomous navigation of ROS, like moving A to B without any manual intervention using navigation stack in ROS. Okay, which is a set of packages helping to move the robot from A to B, okay, without any help, manual help. Okay, so these are the things that we can do using ROS. This is the one thing that we can use. One of the capabilities, and this is another capability like pick and place things. So the pick and place, if you want to do this kind of application, ROS is already have this kind of packages, which is actually built on the inter-process communication framework or the communication framework the ROS have. Okay. So there is a question, can we insert another surface like water, etc. in RVs? RVs is just for visualization, okay? But in Gazebo, you can add surfaces like water. That is possible, okay? And another capability is perception, like from the camera or LiDAR, you can create these kind of 3D maps from the autonomous self-driving cars. So this is a video from a self-driving car. It's creating a 3D map of the environment. Okay, so these things can be easily done using ROS. Okay, yes. So yes. Okay, so and also the ecosystem is like I mentioned, there is a great community around ROS. Okay, yes. So now I'm just quickly planning to wind up the session. Maybe I will take 10 more minutes. Okay, so it's basically like who created ROS and brief history of ROS. Okay, I will quickly go through it, and then I will finally say what are the benefits, okay, of ROS by learning ROS. Okay, so the ROS, actually the basic version of ROS developed in Stanford, okay, called SwitchYard by a researcher called Morgan. Then there is a company called Willow Garage in 2008. They take this project and rename into ROS. Then Willow Garage actually shut down in 2013. And after that, Open source robotics foundation, or Open Robotics is maintaining. Okay, Open Robotics is maintaining the ROS framework. So they're creating software, new ROS software, then maintaining it, all this stuff. Okay, this is the ROS team. Then why we are using ROS? There are many reasons. It is open source. You can avoid the reinventing of wheel. Then we can reuse the packages that created by researchers. Then the code, the package or ROS software is very modular. Okay. Yes. And great community. Okay. And these are some of the distributions of ROS or version names of the different versions of ROS. Okay. Like Ubuntu 16.04, 18.04, Windows 7, Windows 10, like that. ROS also having some distributions. Okay, so in each distribution, there will be some specific versions of the software. So from 2010, ROS Box Turtle, Sea Turtle, Diamond Black, Electric, Furate, Groovy, Hydro, Indigo, Jade, Kinetic, Luna, Melodic, and finally ROS 1, Noitic. Okay, so there is a error. It's actually 2020. Okay, ROS Noitic and ROS 2. So as I mentioned, ROS 2 is an upgraded version. It's actually a different version, different software from ROS 1. It's a new ROS software written from scratch. Okay, it doesn't take anything from ROS 1. It's an upgraded version. It will fix some of the latest, some of the issues of ROS 1, but still there are a lot of area to improve. Okay, but ROS 1 is highly stable. Okay, so these are some of the robot that is supporting ROS or completely working using ROS. There are many robots, by the way. The list only have very few. Okay, these are some of the, and I'm just skipping some demos. Maybe I can show it in the Q&A. These are some of the sensors that is supported ROS. Supporting means you can plug the sensor into your computer. Then you can run a program in ROS. So that will read the sensor, and publish the sensor data as a topic or something. Okay. And you can just connect these kind of IO boards like Arduino or something, Arduino, PIRACY, all these boards into ROS, and you can create a node on these Arduino board. It's very interesting actually. Okay. And the final part, who all are using ROS and what are the benefits of learning it? So obviously, there are many companies are using ROS now in US, India, Europe. Personally, I know many companies are using ROS, many opportunities, and mainly not only the companies, universities are looking for ROS developers. Then the opportunities are very, very high nowadays. Okay, so many companies are using, and if you for simply, like, I'm just taking a web browser just for a second, and let me check for robotics engineer openings, for example. Let me check some of the opportunities, random opportunities from web. Mostly from India, I guess. So this is one opportunity from Botsing, which is one of the company that I partnered with. You can see the requirements. Proficiency in C++, Python, skilled general software development, knowledge of robot operating system, all this stuff. And if you take any opportunity, any job requirement, you can see robot operating system, Python, and everything. Okay. So that's what, like, I just took these things randomly. You can see, and also like the C++ Python requirement. Okay. So all these show the importance of ROS. Okay. You can see C++, then ROS is like, it's all based on the product that they are working on. Okay. So you can find many ROS related opportunities. Okay. One of the Dusi Robotics, they are working on ROS. You can see strong experience in robot operating system, then Linux, Python, everything. Okay. So I don't need to explain anymore, right? So you can see the scope of ROS. Okay. Because software is actually gaining traction in computers and also robots. Okay, so ROS is one of the key tool in that. Okay, so if you want to explore, if you want to know more about ROS, there is ROSCon. You will get idea from ROSCon. There are many. It's an annual conference conducting. And you can find a lot of interesting lectures. And this was taken during ROSCon 2019. I have released, I think, eighth. It was my 8th book. And yeah, that's it. And now I think I can just start the Q&A. Okay, so by the way, like, this is the course that I'm starting next week, ROS Developer Learning Path 2.0. I just collaborated with several companies for internship. After the course, it's a 1-year course, and you can do it, I mean, self-paced mode. It's recorded as well. I mean, I will be recording the live session. It's a live classes, and I will be recording. So I partnered with different robotics companies abroad and also in India. So there is a chance for getting internship if you done this course and do some projects. These are the things that you can expect from the course. Like there will be talks from experts. Then there is a chance for building real robots. Then if you are participating in any ROS competition, ROS-based competition like ENDRA, then that Art Park. I am actually mentoring one team for Art Park. Maybe I can just show you that. Art Park is from IISc. So they are conducting a competition, robotics competition. And I just want to show you, they have published, I think, I'm not sure, they have published the result actually. So one of the team is what I'm mentoring, but the post is not there, I think. Yeah, here is a post. So Robo Jodians. So this is one of the team from Kerala. So I'm just guiding them, and they are in the finals now. Yeah, and the final prize, I think, for winners, I think 10 lakh Indian rupees, and for finalists they will get 4 lakh. Yeah, so yes, so these are the things that I'm planning. This is my side project actually. So the course will be starting next week. So let me know if you're anyone is interested. I can just share the link of the course. It's in the robocademy.com. Maybe I can share, and after that I think we can start the Q&A and the demo. I can show you some simulations. Okay. By the way, yeah. So I'm taking one question. I can also start doing the demo. Just a sec. Okay, so the question is from Midulaj. Suppose if I'm developing model in my PC Ubuntu, how will port the model to my target machine? Let's say Raspberry Pi, for example. Can you just brief that process? In my PC Ubuntu, how will I port the model? Okay, so model means, Midulraj, can you say what you mean by the model? Is it the software or the robot model? If it is software, then if you are writing some ROS code or something in the PC, and it will be mostly working with the Raspberry Pi. There is compatibility. You have to use the same version of ROS. That's it. Okay. Yeah. So I'm just I'm not cleared with the model that he mentioned. Okay, so let's start some demos, and in that meantime, you can ask questions. Okay, starting with, I just want to show you the autonomous navigation. Yeah, just a sec. So currently, you are seeing the simulator called Gazebo. Okay, so this is a simulation, existing simulation of a robot called MIR, and you're going to see the navigation. That is the next topic that is actually planned for the next session tomorrow. So this is the robot, and we are starting the ROS programs to start the autonomous navigation. And I'm starting RVIS to visualize everything. You can see the map of the robot, and this is a robot actually. Okay, so the thing is that I'm just giving a goal position. Okay, so Mohammed is asking, will you upload the recorded session on the WhatsApp too? Yeah, I think the recorded session will be available after this. So you can see after some time, the robot is planning a path. Okay, so actually this is happening on the simulator. Okay, the ROS programs is helping the ROS program is actually reading the goal position and moving this robot in the simulation to the goal position. Okay, you can see it is going through this door. Okay, and the visualization you can see from here. Okay. Yes. So this is one of the demo that I want to show you. Okay. So let me know if you have any questions. This is actually a very big topic. Yeah, go on.
Good evening, sir. Actually, my question is about communicating between ROS publisher or subscriber or nodes. As you mentioned in one slide, it is a globally something. So can we operate nodes use globally, like if someone has it in Dubai, or the robot is in India, so can he operate that robot from Dubai through ROS?
Yeah, so it's okay. I think you have some confusion in that. Okay, let me check that. Let me just take that slide. Okay, so the communication means like this communication is actually inside a computer. Okay, so the communication is happening inside the computer, inside the robot computer. Okay, and if you want to communicate with the robot from an external from an external computer, you can do that. Actually, you can create a network, you can configure some parameters, and then multiple computers can work together. Okay, maybe in a same network. Okay, that is actually possible. So what you mentioned was like a computer in Dubai and computer in India, can we run different nodes? That is actually also possible. Okay, if you set the VPN connections and all, because it's not like these nodes are not connecting over internet or something by default. It's actually connecting in the OS, actually in the OS level, but we can make it work with different computers on the same network. Okay, so if you are in Dubai and a robot is in another location, you can use VPN. Okay, a VPN to make it on the same network, and you can communicate. Okay, but by default, this is the thing, like the nodes are in the computer. Okay, and you can make the same configuration to multiple computers. You can do the communication from a distributed set of computer. That's also possible.
Okay, sir. Clear. Thank you.
Okay. Yeah. Okay. So I think we are running out of time. So from Wahin, is the demo with the robot you just showed already on ROS as an example that we can run? Yes, it's already available. Okay. So this is the GitHub repository. Okay. This is the simulation. This repository having hardware as well as software. I mean, hardware interface and also the simulation, everything is there. Okay, this is what I'm following. Okay, like that, there are many examples available. Okay, and also in this session I couldn't talk much about the hardware interfacing. Maybe next session or something I can just mention. Maybe tomorrow's session I can just talk about how to create a robot and make it autonomous. A very abstract idea, not in detail. These are some of the very basic robot that you can make and make it compatible with ROS. Okay, and this is actually there in my book called ROS for Absolute Beginners, which is suited for who are starting with ROS. Okay, the second edition is actually coming. Yeah. Okay. So I'm taking one more question. Is it compatible with all the sensors? So currently there are list of sensors compatible, and also we can make it compatible. We can write programs easily. Okay, we can create ROS compatible sensor driver very easily. Okay. Okay, then guys, I think we have to conclude. Okay, we have to conclude. So thanks for attending this session. Okay, I hope this gave some idea to start with ROS. Okay, so regarding the course costing and all, I think Bunsen will send another link. So he will be handling this. Okay, he will send a link so that you can check out. Okay, this is a 1-year course, and you can just imagine how big is this topic. Okay, so you can just go through the link that I have given. So that is having all the information. Okay, for the registration, I think Benson will send a link. So through that you can register. Okay. Okay, then. Yes. So thanks for attending. So over to Benson.